Hello and welcome back to my channel. Today we're going to revise electron arrangement on the atoms. So at key stage 3 and key stage 4 you're expected to learn about the first 20 elements and how the electrons are arranged around the nucleus. So on the first shell, so these are the rules that you need to follow when arranging electrons on the shells of atoms. On the first shell, you can put a maximum of 2 electrons. On the second shell, you can put a maximum of 8. Third shell, maximum of 8. And the fourth shell, maximum of 2. Because of course you're looking at the first 20 elements, and if you add all these numbers up you should get 20, which would represent calcium, which is a 20th element. Okay, now let's have a go at arranging electrons on these atoms. So these elements here are the noble gases, some of them. Okay, so you've got helium. Helium's got 2 electrons. Neon have 10 and argon have 18. The noble gases are the stable ones on the periodic table. The noble gases are unreactive because they are stable. They don't need to give away electrons. They don't need to accept any. They are good. All right. So in terms of the electronic arrangement, so helium, so it's He, it's 2, and I'll draw the atom here. So it's one shell with a dot in the center. The dot represents the nucleus. Okay, and on the shell, we place the electrons. So this is the shell. And this one here is the electron. Okay. Next one is neon. So that's Ne, 10. And first shell with a dot in the center for the nucleus. First shell's got 2 electrons. Second shell have 8. If you add them all up, you should get 10, right? And this is the outermost shell. Okay, and it's got a maximum of 8 electrons there. Okay, and then the electronic arrangement is 2, 8. 2, 8. You add them up, you should get 10. All right, now I'll have a go at drawing 2 examples of group 1 elements. The group 1 elements are, they include lithium, sodium, and potassium. So those are the ones that you'll come across in school. So lithium's got 3 electrons. So I draw the atom like so. First shell's got 2. Second shell have 1. So we're still following the rules of how many you can put on each shell in terms of the maximum number. So if it's got 3 there, it means I can only put on 3 electrons. First shell 2, second shell 1. Add them up, you get 3. Next one is sodium. Na is sodium, and sodium's got 11 electrons, or 11 is the atomic number, which basically means that the atomic number represents the proton number as well as the electron number. First shell, put the X's on, and we work our way outwards. Second shell will have maximum of 8, And then on the third shell, just like lithium, it's got 1 electron. So the electronic structure is 2, 8, 1. You add them up, you get 11. I'll do calcium next. Calcium is the 20th element, right? Calcium is in group 2. If it's in group 2, it means it's got 2 electrons in its outer shell. So I'll draw the atom again, another atom. So on here, 2 electrons in the first shell. Eight in the second. Eight in the third. This is quite big. And 2 in the fourth. If you count all the x's, you should get 20. So the electronic structure is 2, 8, 8, 2. Add them up, that should add up to 20. So that's the electronic arrangement of elements on the periodic table, or rather the first 20. So these 2 electrons that calcium have right here makes calcium unstable. Calcium will readily give away these 2 electrons, and an element that it would readily give it away to would be oxygen. Oxygen needs 2 electrons, right? So if I draw, so I'll rub this out from here, and I'll draw oxygen. Oxygen's got 8 electrons, okay? So if I draw the atom now, I'll show you how that's done. So first shell's got 2, and remember they need to add up to 8, okay? So it's got 2 here, or I'll use dots to represent the electrons instead. Or let's make it a little bit more fun. I'll use a different color. Actually, I'll stick with that for now. So I'll need 2 shells and a dot in there for the nucleus, and then make it a little more fun. Okay, so 1 there, 1 here, then 2 there. Remember, it needs to add up to 8. So go 2, 4, 6, 8. Okay, now oxygen needs 2 more in order to fill its outer shell. Oxygen needs to be stable, and in order to do that, it needs these 2 electrons that calcium is more than happy to get rid of. So now I'm going to transfer them over here like so. So this is called ionic bonding, where an element with free electrons willingly give away these free electrons to another element who needs them in order to fill its outer shell. All right, so now, so before oxygen was 2, 2, 4, 6, 2, 6. Now oxygen is 2, 8, right? So it actually took on the status of a noble gas, the status of neon. And then over here, calcium forms a positive ion. Calcium have given away the 2 electrons in its outer shell. Now it has a new electron arrangement or structure, which is 2, 8, 8. Calcium is now Ca2 plus because it gave away 2 electrons, and oxygen is now O2 minus. So calcium forms a positive ion and oxygen forms a negative ion because it has accepted electrons, making it causing it to form a negative ion. Okay, hopefully that helps. If you've got any questions, then please put them in the chat. I will respond. Also, please don't forget to like and subscribe. And thank you once again for watching. Bye-bye.